And I get to come down here from my home outside of Seattle several times a year to chat with folks like you, and it's always a privilege to do that. This is one of those 3 places on Earth where humans are launched into space. Of the 3, it's the only one open to the public. You know, there's one in Central Asia used by the Russian Space Agency, and there's one in China. But this is the only place on Earth where you can go and see the enormous effort that it takes to put human beings into space. Thousands of scientists, engineers, and technicians here at the Kennedy Space Center, using huge pieces of equipment, gigantic buildings, and going through tens of thousands of procedures in order to prepare a spaceship for launch. You know, astronauts don't live and train here. Astronauts come here for the sole purpose of strapping a rocket on our bottom and riding it into space. And so we owe a great debt of gratitude to the folks here at the Kennedy Space Center. They do a great job of preparing these vehicles and making them as safe and reliable as they can be. And we know it's dangerous work. Some of us wouldn't do it if it wasn't dangerous, I guess. That's just the nature of the beast in some cases. But those of us who realize that, in fact, we're putting our tail on the line, we think that it's worthwhile. We think that, you know, the lessons learned from space travel and the benefits that come back to the planet as a result of space travel are worth the risk. And so that's really the reason that we do it. I got to fly twice on the shuttle. I flew on the Space Shuttle Challenger on its 2nd flight back in 1983. On the day that Sally Ride became the first American woman to fly in space. And I'll tell you what, that was fun to be there. It really was. We had a huge turnout of people for that flight. One of the largest crowds ever to witness a space shuttle launch came to see the first flight of an American woman. Lots of media attention. Even the music industry got involved. You know, the #1 song was Ride, Sally, Ride. So, you know, this was a special event. The newspapers and the TV, they called us Sally and the 4 other guys. Well, we just laughed because we knew you sit close to her, you get your picture in the paper. It was fun. This was really, it was a fun time. My 2nd flight was on the Space Shuttle Discovery, and by the way, that's the one that's up there now. It was the 2nd flight of Discovery, and it was the first time that we had 3 different nationalities represented on a space flight. We had Patrick Baudry, a French test pilot. We had His Royal Highness Prince Sultan Al Saud, the nephew of the King of Saudi Arabia, on board, plus 5 NASA astronauts. One of those 5 NASA astronauts deserves special mention. Her name is Dr. Shannon Lucid. Dr. Shannon Lucid is special. This morning she was sitting in the Mission Control Center in Houston. She was acting as a capsule communicator between Houston and the crew up on the space shuttle and the International Space Station. She flew 5 times in space. Her first flight was with me, but she went on to fly 4 more. On one of those, she set the American record for the longest space flight by man or woman. You know? After she got through flying, NASA made her the chief scientist for the whole agency. I think that's really great. And this is for a woman who earned her PhD in biochemistry and taught herself to fly and got a commercial pilot's license and got married and had 3 kids. Before NASA even decided it was okay for women to be astronauts. And here's a woman who was born in a Japanese prisoner of war camp in Shanghai, China during World War II. Boy, that's a great story, don't you think? Yeah. That's a great story about the human spirit. That's a story about someone who just, in spite of starting out in her life under the worst of circumstances, overcame lots of obstacles and did something really neat. Well, my flights were mostly about big communication satellites. In the early days of the Space Shuttle program, we carried up commercial satellites. We stopped that after the Challenger accident because President Reagan decided he didn't want to risk astronaut lives doing commercial work in space. So we put those commercial satellites now on expendable rockets. Astronauts call them dumb rockets because there aren't any people on board. But in the early days, it was really important, and we carried 5 of those for 5 different countries. They're big around as one of these tables, stretch all the way to the ceiling when you telescope them out. Cost $80 million a piece, plus postage and handling. $50 million postage and handling to put a communication satellite into space. $10,000 a pound. Good rule of thumb. $10,000 a pound to put something into space. So at any rate, we carry these guys up into space. We'd spin them like a top, stabilize them like a gyroscope, shoot them out of the cargo bay, and they have their own rocket engine that would ignite, and carry them up to their operating altitude. That's 25,000 miles above the center of the Earth. 25,000 miles above the center of the Earth is called geosynchronous altitude. And that's because it takes precisely 24 hours to make one orbit, while the Earth turns once below. And so the satellite stays over the same spot on the equator all the time. We have a family of these satellites that surround the planet. We use them like giant reflectors to send data and audio and video signals around the Earth. Very important part of the architecture that helps bring the world a bit closer together. So that was interesting work. When they were on their way to their upper orbits, we got to do some other things. We used a Canadian-built robotic arm to take satellites out of the cargo bay, lift them up and release them, fly the space shuttle away. Let those satellites free fly for a day, and then at the end of their data collection period, we'd fly back in, snuggle up next to them, fly formation at 17,500 miles an hour. Boy, that's a fighter pilot's dream for you. Reach out and grab the satellite, slip it back into the cargo bay, and bring that satellite and the data back down to Earth. On my second mission, the little satellite that we put out there was an X-ray telescope. And X-ray telescopes are cool because that's the kind of thing that we use to study black holes. This was the first time that an X-ray telescope had been in space. We released it up there and it turned and looked back towards the center of our Milky Way galaxy and began scanning, looking for the black hole that's located there. And that scanning pattern got smaller and smaller until finally just the slightest little wiggle would lead to a huge influx of X-ray radiation showing us just where the black hole is at the center of the galaxy. Now since that time, we've built much more capable and much more powerful X-ray telescopes, and they're up there today, being remotely controlled from the ground, looking out into the heavens, distant parts of the universe, seeking black holes and finding them everywhere. We have just found all kinds of black holes up there. This is science reality. This is not science fiction. We know that they're there. We know they're extraordinarily powerful. We know that they have a gravitational field so strong that even a particle of light that travels at 186,000 miles a second isn't going fast enough, because the gravitational field will suck those particles right into the black hole. Black holes eat entire stars. Black holes eat entire star fields. And the good news is, there aren't any close to where we live. Yeah, that's really good news. Well, we did some other things too. We spent a lot of time doing medical experiments, pharmaceutical experiments. We had a little pharmaceutical factory on my first flight. Human physiology, we carried up and also had some animals, wild animals that we had up in space. You saw some of that in the movie here. Tadpoles that swim upside down and do circles and that sort of thing. We had a colony of ants on my first flight. Very interesting to work with this kind of thing. Lots of science that's done up there, even on the most routine of flights. In your spare time, you're working on some sort of a science experiment. On my second flight, we flew over the island of Maui. There's a big telescope on the top of Maui. It's an United States Air Force facility, and they shot a laser beam up to the Space Shuttle Discovery. We have a side window and a side hatch that's 6 or 7 inches in diameter. And we mounted a mirror, a real shiny mirror, in that side window, and they bounced a laser beam off of that mirror while we're coming over the top at 17,500 miles an hour. That's good. That's kind of interesting. And we were oriented in just the right position so that laser beam not only came up and bounced off of our little mirror, but it went straight back down to that same telescope. So they could measure what happens to these laser beams as they go in and out of the atmosphere. Because laser communications is something for the future. Laser communications is going to be a big part of the way we talk about communicating in the decades to come. But things are changing out there, and it's fun to be a part of it. We also spend a lot of time looking out the window. We call that Earth observation. If we didn't call it Earth observation, we'd have to admit that we're looking out the window and getting paid for it. Yeah, we take a lot of photographs of scientists, oceanographers, geologists, and atmospheric scientists, and climatologists. All sorts of people need pictures from space, and we take a lot of those. We bring back thousands of pictures from every mission. Pictures of the oceans and river valleys and mountain ranges and volcanoes, standing waves in the oceans and coloration differences out in the oceans and all sorts of things that you can see from space. You know, how many of you have heard that the Great Wall of China is the only thing that you can see from space? Yeah, you've heard it. Anybody else heard that? You heard it? It's wrong. It's just flat wrong. And we believe that story's been around since before there were any humans up there to see. But that's a story that will not go away. It's stated so often that it's stated as truth and it's wrong. We fly along up there at 17,500 miles an hour, 300 miles a minute, 5 miles a second. We can turn our head from left to right and see across North America. But when you look straight down at the planet, you can see extraordinary detail, amazing detail. Highways and bridges and dams, you can see from space. There's a bridge very near my house where I live now out in the state of Washington. It's a floating bridge. It's called the Hood Canal Floating Bridge, and it is 1.5 miles long and 2 lanes wide, and in order to see it, you just stick your nose out the window. We can see the runways here at the Kennedy Space Center, the big buildings where we put the shuttle together. Lots of details that you can see from space, and yet the story persists that the Great Wall of China is the only thing that you can see from space. How about large ships at sea and condensation trail behind airplanes out over the Atlantic and the Pacific? Yeah, a lot of things that you can see. And I'll tell you what, it's fun too, it's fun. And we take all those photographs in order to document what's happening to our planet. We look out the window at the curvature of the Earth, and just above that curvature, we see the atmosphere of the Earth. It's a thin, light blue layer that looks like haze. It's thinner than your little finger. And it's the only thing that makes life possible on this planet. This atmosphere, which is extraordinarily thin. Most people believe that the atmosphere is vast, and clearly, folks, it's not. It's compared to the skin of an apple. Did you know that half of all the molecules that make up our entire atmosphere are within only 2 or 3 miles of the surface of the Earth? That's thin, isn't it? You bet. You see, gravity attracts all those molecules and pulls them down close to the surface of the Earth, where the atmosphere is pretty compact. The upper end of the atmosphere, up there 50 miles, is very rarefied, but most of those molecules are down here close to the Earth. You know, when we fly along in a jetliner at 35,000 feet, 7 miles above, we're way above the vast majority of all the molecules that make up our atmosphere. Yep. They're all down there within 2 or 3 miles of the surface of the Earth, right down close to all our tailpipes and smokestacks. Yeah. So when scientists tell us that we need to be careful about what we do with our atmosphere, we need to be careful with what we do with our atmosphere. There's no question about that, okay? Because it is thin, fragile, and we need it a lot. Well, at any rate, this is a chance for you folks to ask some questions if you'd like about living and working in space or other personal reflections. If you want another lecture, I've got one of those that I can give you too. so just ask your questions and I'll do my best to answer them.
All right, raise your hand if you want to. Okay, we got a question. We got several.
How do you know when it's night and morning in space?
If the sun is out, it's not morning or daytime, it must be night. But it's just a matter of whether it's light or dark, right? That's daytime and nighttime. But the question really, though, is what time is it down on Earth if it's dark where you are? Because if it's dark where you are, it might be midnight right down below you. But where your family is, it might be some totally different time, right? So astronauts carry 2 watches. We wear a watch on our left hand and a watch on our right hand. And the watch on our left hand has what we call mission elapsed time. It starts at midnight at liftoff. So it's the number of hours, minutes, and seconds, and days that you've been in space since liftoff. And everything that you do on your mission is based upon that time. 8 hours and 23 minutes after liftoff, somebody's going to prepare dinner. Okay? That's the way you do it. The other one has the time in Houston, Texas, where the Mission Control Center is, and that's where our families are typically during the flights. So if you want to know what Mama's doing, you can look at your watch. Are the kids in school? Yeah, the kids are in school today. You can look at your watch and tell that. So that's the way we tell time, day and night.
You know, recently I saw on the International Space Station, one of the astronauts had 3 wristwatches on.
Oh, he had 3. Yeah. Well, he may have been a Russian. He may have had one for the Moscow time too. Because you know we've got a mission control center now in Moscow as well as one in Houston. So yeah, that may be the reason. Being able to take up 3 watches would be good. I was only allowed to take up 2. They were my watches. I bought them, so I got to keep them after the flight. And those watches had flown in space, and those watches are good watches. Yeah, my son has one and my son-in-law has one. I've got 2 more left. Anybody want to buy one?
Okay, we've got a question right here, and I want you to notice his jacket. It says United States Space Command, so you better answer very carefully. Okay, there you go.
All right. Were you ever scared on that flight?
I was never scared on my flights, but I was scared to death on my launches. Launch is really scary. I will guarantee you that. And anyone who says it's not scary to go out to that launch pad, sit on top of that rocket, they're kind of kidding you a little bit, okay? Because it's really scary. Did you know that a space shuttle has the explosive power of a nuclear bomb? It does. It's really, really powerful. And when the solid rocket's motors go off, you're going to go somewhere. You're not sure where, but you are going to go someplace, yeah. We're doing 100 miles an hour when we get to the top of the launch tower. We've only gone about 130 feet. 130 feet after liftoff, 100 miles an hour. I don't know any car that's going to do that. Anybody know a car that'll do accelerate to 100 miles an hour in 130 feet? No, this thing really is powerful, yeah. And you know, our engines burn for 8.5 minutes. 8.5 minutes after we leave the launch pad, we're doing 17,500 miles an hour. We're 200 miles in the air, and we look out the window, we can already see Africa. Wow, isn't that something? Yeah. And I tell you another thing I learned on my 2 space flights. It's impossible for a human being to hold his breath for 8.5 minutes. I tried twice. Can't do it.
Okay, next question here.
Just have a question about zero gravity. What effects do zero gravity have on whatever fresh produce you bring up? Does it have the same effects as like on the human body?
I haven't talked to anybody about decalcification of fresh fruits and vegetables. We're only allowed to eat that on the first day. We're allowed to cake up apples or bananas or whatever, fresh fruits and vegetables, but it has to be consumed on the first day of the launch, or it has to go into the wet trash, because they don't want us to get sick. But I'm not sure just what I don't know if it goes bad faster in that environment or not. I only know the rule.
How much training do you want to go through before you can be an astronaut, go to space?
Well, it takes about close to 20 years of education total. That's you better like school. You really better like school. And then you're in training for about 5 years as an astronaut before you get your first opportunity to go fly. But that's not 100% training. It's also your technical assignment. Like mine was to work with the Canadian government on the design and development of the Canadian arm. So you're doing worthwhile things at the same time that you're involved in training and getting ready to go fly in space.
What would you say is the most unexplainable thing that you've seen or discovered while you've been out in space?
While I was there, I was kind of baffled by something that later turned out to be not such a big deal. They explained it all to me. We were over the Indian subcontinent at night. That's the question back there. That means it was dark outside over the Indian subcontinent. Shannon Lucid and I were looking out the window when a very bright object came through our altitude, went down towards the Earth, broke into about 6 pieces, and each one of those was intensely bright, white hot, and then they all went out. I thought maybe, see, I was a military guy, somebody shooting missiles out here. Yeah, this is one of those MIRVs, multiple re-entry vehicle nuclear weapons that someone's testing out here. Maybe Indians developed something, that we don't know about. No, it's not true. It was a meteor that came through our altitude, and even though we were 200 miles up, even at 200 miles up, you've still got molecules of air up there. Okay, very, very rarefied. But this thing is coming in like we're going 17,500 miles an hour. This thing is going 50,000 miles an hour. Okay, and it's going so fast that even the most rarefied atmosphere begins to affect its surface. And so that's what we were saying. And then as it got further into the atmosphere, the forces, decelerating forces, broke it into pieces, and that's what we were saying. And it was spectacular. And we didn't know what it was until they explained it to us later.
This is a good question.
Uh-oh.
Good question. How much do you want for that extra watch you have?
Well,
not too many people can say they have one.
We got a question, and I think you can elaborate a little bit more on that. What kind of salary does an astronaut have?
the same as you get anywhere else in the government at the same rate or same grade. I was a colonel in the Air Force, so I got colonel's pay for flying and for being an astronaut. There was no additional bonus, although I did get extra pay for going into space. I got $3.42 a day for every day I spent in space. That was called per diem. I got that per diem because the government was providing my lodging and my food, so I didn't get the full per diem. I only got the incidental expense part of it, for laundry and so forth.
And they didn't cover your mileage?
And no mileage. At 51 cents a mile, I tell you, you could make out there. There's no question about that.
How do you feel the need to sleep in a non-weightless, in the weightless atmosphere?
The first couple of days, I really slept well. I mean, the adrenaline rush that you're in on the first day is extraordinary. And so you're fatigued. You're mentally fatigued and physically fatigued by the time the end of the day comes, and you're ready to go to bed. Now that only lasts a day or two, and then after that you begin to start thinking, I can rest and sleep when I get home, but I only have so many days that I can look out the window and watch the beauty of the world down below. So by the end of the flight, I'm probably not sleeping more than 4 or 5 hours a night, but my body's not working hard, My pulse rate is down, my blood pressure is down, I'm not stressing the muscles of the body, and so it's a very easy place to be.
Okay, these are our guests from Colombia. Okay, and again, bienvenidos. And their question, as I understand it, they're asking about budget for space flight, and we're getting into political issues here because
that's okay. I'm a free agent.
She wanted to know how much it costs for a ticket to go to the moon.
Oh wow! I have no idea. We don't have any seats available, I'm afraid. And it's not clear to me when we're going to have any. We have a White House statement from the last administration that says that we want to be back on the moon by 2020. But we've never had a budget that will allow us to do that. And there's a big blue ribbon panel called the Augustine Commission, which is working right now to make recommendations on what NASA can do and what NASA can afford to do. And I'm a private citizen. I'm long since retired. I only do what my wife tells me to do, and she tells me I can say anything I feel like. So I'm going to tell you that we do not have enough budget today to ever go back to the moon or to go onto Mars, in spite of the fact that we have plans to do so. And the reason is that NASA's been on a level budget for the last 12 years. Has not even kept up with inflation. And right now, NASA gets 0.5% of the federal budget. We can't do this. We can't go back to the moon and onto Mars and build new rockets and new spacecraft and do advanced technologies required to do it with less than 1%. It just can't be done. Apollo cost us about 1.5%. When I became an astronaut, we were getting about 1%. Now we're getting 0.5%. So, let's face it. There are limitations as to what you can do within the budget that you got, and I don't know what this administration is going to decide to do. But I think that we really ought to either do it or get off the pot. We really ought to, because I think it makes no sense for us to say that this is what we're going to do. We've got a grand plan to do this, when everybody who's working on the project knows that there's no way to get there from here. So that's John Fabian's personal opinion. I told you I had another lecture to ask.
Okay, we got another question. Hopefully it won't be a pain or get off the line.
Yeah, it was gonna be. So what happens when the shuttle program ends? I think it's 2011 when it's supposed to end. And what's the next phase? Are we going to keep going to outer space, or are we going to, or are we pausing?
Well, you've asked a good question. You've asked a good. We have 6 more flights to the International Space Station with the shuttle, and the schedule has us making the last of those 6 flights in 2010. And the current plan is to give those space shuttles to museums after 2010. And the plan, although I've already talked to you about the reality of that plan, is to build a new set of rockets and a new capsule to put astronauts in space to allow them to go up to the International Space Station. The earliest that could be ready, according to what I just read this morning, is 2017. So we would have at least 7 years without any independent access to space. And the plan is that we'll fly up on Russian spacecraft. That's the current plan. And I'm an engineer. I've been working in the space business and the aviation business for my entire life, and I'm over 20 years old, so I've been doing it for a while. But there's no way we're going to be ready by 2017 either. That's just not the way programs work. So, you know, we're looking at 2020, not being back on the moon, but having the next generation of spacecraft ready to go into space and bring us up to our International Space Station. So that's the plan. The plan is that we're going to have new rockets, and in the interim, we're going to fly with the Russians.
That's not a bad thing. We've been flying with
the Russians, though. The Russians have very dependable vehicles, and but the problem is that they only carry up 3 people at a time, and the space shuttle will carry 7 people up at a time, and we've got the International Space Station has 6 crew members, so that takes a lot of getting up and back in order to support it. And we're buying. The Russians aren't giving us those space trips either. We're buying those as a product.
So what you're saying is no Bucks, no Buck Rogers.
Yeah, I think that's what people have said.
Okay, we've got a final question here. And before we take this final question, I would like to invite you to meet us outside. We've got some fine folks from Kodak, and we can have your photos taken. You can have a brief photo session with your own camera. We ask that you only take 1 photo per family. However, Kodak is out there to take a picture with you and our astronaut, John Fabian, and they will make a really good job of it. So if you want a souvenir of your lunch encounter with John Fabian, then we'll accommodate you outside after we take this last question.
Just a quick question. I work for the Jacksonville Aviation Authority, just north of here.
Yeah.
And Cecil Field is one of the airports we own.
Mm-hmm.
And we're in the final processes of getting that certified as a spaceport.
Yeah.
And there's a lot of interest, especially from like Richard Branson,
Yes.
who wants to do horizontal
Right.
launches from there. Do you see any point in time where the government would give a lot of the heavy lifting and stuff into space using that?
I don't think we're. I don't. Carrying people up to the edge of space on suborbital flights is something which is very near to being a reality. We're within just a couple of years of that, and they're already selling tickets. Virgin Atlantic and Richard Branson selling tickets for these flights, and they're essentially sold out for the early part of that program. $250,000 a ticket. And don't worry about that. It's going to come down like plasma TVs do. That's very real. On the other hand, taking off horizontally from a runway and putting payloads into space is way far out in terms of our technical ability. We don't have anywhere near the mass fraction to do that. You have to realize that you only get about 3% of the mass into orbit from what you lift off with. And if you're going to lift off with something that has wheels on it or horizontal takeoff, the mass fraction is even smaller than that. So, you know, I just don't see that happening. I think that there is clearly a place for the commercial space industry, and we ought to be able to do that from multiple facilities, and certainly no reason that you shouldn't be able to do it from Cecil Field. But I don't think that we're going to be able to get large payloads to orbit that way.
Okay, a round of applause for John.